Unit 4B, Lesson 1, Completing the Square. In the previous unit, we worked a lot with factoring, and we could use factoring in the zero product property in order to solve quadratic equations and even equations of higher degrees if we broke them down. This unit, or this lesson, we're going to use completing the square, which is just another method that allows us to solve quadratic equations, ones that probably can't be factored easily. Here are some steps we're going to take to solve quadratic equations by completing the square. The first step is we have to make sure that our leading coefficient is 1. If our leading coefficient is not 1, then we have to divide by that a value in order to make it 1. The second step is to get the x terms on one side of the equation and the constant on the other. So we want to get our x squared and our x term on one side of the equation, typically the left side when we're organizing, and then get the constant on the right side of the equation. The third step is we're going to get some help from T-Swift and add a blank space to both sides of the equation. Then we're going to fill in that blank space with the expression b over 2 quantity squared. Once we add that to both sides of the equation, on the left side it's going to create a perfect square trinomial, and we're going to factor that perfect square trinomial just like we did in the last unit. Step 5, we're going to take the square root of both sides of the equation. And then step 6, now we're going to simplify and solve for that value of x. Lots of steps. These will make more sense as we go through the examples. First example, we're going to use completing the square to solve the quadratic equation. We have x squared plus 4x plus 3 equal to 0. This quadratic equation actually could be factored into x plus 3 times x plus 1, use the zero product property, get x equals negative 1 and x equals negative 3, but we're going to use the process of completing the square to show that process with an easier example. So the first thing we want to do, make sure the leading coefficient is 1, which it already is, so our first step is done. Next, we want to isolate our x terms on one side of the equation and get our constant on the other. So the first thing we're going to do is subtract 3 to the other side. Now that we have our variables on one side, the constant on the other, now we get the help from T-Swift, and we're going to add that blank space to both sides of the equation. We have our blank space here, and then we're going to add another blank space to the right side. The reason we have to do that, if we add something to the left side of the equation, we have to add that same quantity to the right side to keep this balanced. The value we're going to add is b over 2 squared. Before we move on to the next step, factoring, we're going to simplify this expression. So on the left side, we have x squared plus 4x. And if we simplify this, 4 divided by 2 is 2, 2 squared. We're just adding a value of 4 here, equal to negative 3 plus 4 here. On the left side, now we're going to factor this, and this is going to factor into x plus 2 times x plus 2. Factors of 4 that add up to 4, 2 and 2, and then that's equal to, that's a good equal sign, that's going to be equal to 1. Negative 3 plus 4 is 1. Now, if we have some factor being multiplied by itself, the shorthand way of writing this is just x plus 2, that quantity squared. We have something times itself, 7 times 7, we can write 7 squared. X plus 2 times x plus 2, we can write that as x plus 2 quantity squared equal to 1. Now, typically, what we're going to do once you understand this process, we're going to skip those last two steps. Once we add this b over 2 squared, that is always going to create a perfect square trinomial in this case, meaning it's going to create a trinomial that is going to be factored into some factor times itself. So once we have this expression with the b over 2 quantity squared added, we can always break it down and skip to this step. If I have an x squared, this is going to break down into an x. If my b value is positive, this is going to be positive. I take my b over 2 quantity, 4 divided by 2 gives me 2. So we can always skip from now on this step to get to here. So that last part was step 4 in the process. Now we want to go to step 5. We're trying to get x by itself, so we have to get rid of that squared. And the way we do that is by taking the square root of each side of the equation, because the square root and the squared cancel each other out, leaving us with x plus 2 on the left side of the equation equal to, when we take the square root of a variable squared, we have to account for the positive and the negative value. Anytime we have an x squared and we're taking that square root, we have to always account for the positive and the negative, and then the square root of 1 is 1. This positive and negative part tends to be a little confusing. We'll go through that more in depth during class. Now the last thing we need to do to get x by itself is subtract 2 to the other side. So we have x equals negative 2 plus or minus 1. Now if we simplify that, negative 2 minus 1 is negative 3. Negative 2 plus 1 is negative 1. So notice these two answers, negative 3, negative 1, those are the same two answers we would have gotten if we would have factored this into x plus 3 times x plus 1, then use the zero product property. We'd still get x equals negative 3, negative 1. Factoring would have obviously been the easier process in this case. We're just using a simpler example to go through the process of completing the square. That way when we get to more complicated examples, we can still use this process. Now to example 2, x squared minus 9x plus 14 equal to 0. First step, make sure the leading coefficient is 1, which it is. Next step, we want to get the x terms on one side, the constant on the other. Once we have our variables on one side and constant on the other, then we're going to take our b value, which is negative 9, divide that by 2 and square it. So we're taking b over 2 squared, adding that to both sides of the equation. Now on the left side, we said this in the last example, we can skip the next two steps because when we add b over 2 squared, that's always going to create a perfect square trinomial. So we have x squared. This is going to break down into an x. My b value is negative, and then I'm going to put my b over 2 value. So I see my b over 2 value is negative 2 or negative 9 over 2. I'm not going to put that negative twice. I already accounted for it from the original b value. So this is going to turn out to be 9 over 2. So x squared minus 9x plus negative 9 over 2 squared factors into x minus 9 over 2 quantity squared equal to negative 14. Now we have to simplify it a little bit. This is going to be plus 9 squared is 81. 2 squared is 4. So applying those exponent properties we talked about earlier in the year. In order to add negative 14 plus 81 over 4, we have to get a common denominator, which is 4. So negative 56 over 4 plus 81 over 4 simplifies to 25 over 4. Now to get x by itself, we have to take the square root of each side of the equation. Now we're going to have that squared out of the problem. So now we have x minus 9 over 2 equal to, remember we have to account for the positive and the negative. A property of radicals, if we have a fraction, I can break this up into the square root of the numerator divided by the square root of the denominator. The reason we do that, the square root of 25 becomes 5, the square root of 4 becomes 2. So when we take the square root of 25 over 4, it actually simplifies down to a nice number. Now the only thing we have to do to get x by itself is add 9 over 2 to the other side of the equation. So we take 9 over 2 plus 5 over 2, which is 14 over 2. Then we take 9 over 2 minus 5 over 2 and get 4 over 2. 14 over 2 simplifies to 7. 4 over 2 simplifies down to 2. So here are our two answers. Again, in this original problem, we could have factored it to get the solutions. We're just going through the process with easier examples. Another point to make is that you want to leave these values as fractions throughout. Do not change these to decimals. If you leave them with fractions, because of these properties of radicals, when you take the square root and try to combine like terms, it's just easier if you're working with fractions. Now to the third example, we have 2x squared plus x minus 6 equal to 0. First thing we need to do in this example is divide the whole equation by 2, because we need to make that leading coefficient a value of 1. And as long as we divide the left side and the right side by the same value, we're okay. So now we have x squared plus 1/2 x minus 3 equal to 0. Get our variable terms on one side, constant on the other, so we have to add the 3. Now when we try to add this blank space, it's going to be a little trickier because we have a fraction. So we have to take our b value, which is 1/2, and divide that by 2. And I'm going to change this to 2 over 1. Because if I have a fraction divided by a fraction, I can take my fraction, which is 1/2, and multiply by the reciprocal of the denominator, which would be 1/2. 1/2 times 1/2 just simplifies to 1/4. So when I take 1/2 divided by 2, it simplifies down to just 1/4. What you're going to start recognizing, if you have a fraction and you're dividing it by 2, essentially you're just going to multiply 2 into the denominator, because you can multiply the whole thing by 1/2. Multiplying the numerator by 1 is not going to change that. So we're adding 1/4 quantity squared to each side of this equation. When we do that, the left side, I have a typo, this should have been an x squared. This is going to factor into x. Our b value is positive, so this is going to be positive. Our b over 2 value is 1/4, so we have our 1/4. So x plus 1/4 quantity squared equal to 3 plus 1 over 16. Now we have to get a common denominator, which you can see off to the right, which is going to be 16. 48 over 16 plus 1 over 16 is 49 over 16. Now we need to take the square root of each side of the equation. And just like the last example, we're going to break this up into the square root of the numerator divided by the square root of the denominator. So on the left side now we have x plus 1/4 equal to plus or minus the square root of 49 is 7, the square root of 16 is 4. We subtract the 1/4 to the other side, so we have negative 1/4 plus or minus 7/4. Negative 1/4 plus 7/4 is 6/4. Negative 1/4 minus 7/4 is negative 8/4. And then if we simplify each of those, 6 over 4 simplifies to 3 over 2. Negative 8 over 4 simplifies down to negative 2. So here's our two answers to this quadratic equation we started with. If we graph this original equation, 2x squared plus x minus 6, these would be the x-intercepts of the graph. So completing the square, first make sure the leading coefficient is 1, then get your x terms on one side, your constant on the other, then you're going to add the b over 2 quantity squared term to each side of the equation. Once you add that, you're going to factor the left side because it's a perfect square trinomial. Once you have it factored and the right side simplified, now you take the square root of both sides of the equation, and then you solve to get x by itself.